Who? Okay, I think we're set to get started, guys. Thank you for waiting. We're going to start with free response question 3.
What is this? Yeah. Is this from the store? Yeah. Can you bring it back here and say can you send me out of any other period?
Okay.
Okay, so let's just read through free response question 3. We are live, so no surprises. Yes. Sure. Rejection region is,
Like the table that you showed us?
yeah. Let me do this. Let's say you get in your normal curve, you do your test, and you get your you get your, let's just say for x bar, okay? And your x bar would be, let's just pretend it's here. Okay, this would definitely be your t statistic, whatever that is, your test statistic. This would be mu x bar down over here. This area right here is what we call the rejection region. And basically, if you're tested, I'm totally crazy. Hold on. This area right here equals sigma. Okay? So any test statistic that's in this region, let's just say we found out that x bar was here, giving us a t star. So x bar 1 is in the rejection region. So in other words, x bar would be greater than this. I have a way of saying that. Oh, it's not x bar, it's t star. Sorry. T star would be greater than that.
Is that kind of like one significant for those?
I'm sorry?
Is it like one significant for you, not significant for standard?
It's not necessarily a standard deviation. If we had a 95%, if you had a 5% upper tailed test, then T star here would be somewhere, or the rejection region would begin somewhere around 645. So any T star that gets us into 1.645 would be rejected. Okay.
I wanted to ask for the rejection region.
Uh-huh. You would take an inverse t. So rejection region. Let's do that with a calculator. What would be the rejection region? HA would be x bar is greater than, I'm sorry, not x bar. Mu is greater than mu naught. And we have alpha equals 0.05. If we go over here, basically, or if we look at this chart, basically this area here has to be 0.05. So I think the program is going to work nicely for that. That's inverse t now, right? So now we're doing for an inference. We're going to do a one-tail test. and we want a 0.05 alpha level. And, oh gosh, we didn't have a degree of freedom, right? Let's just put that post hoc at 24. Okay. So while that's doing that, we're going to say that n equals 25. So the rejection region t is greater than 1.711. So what that says is that anytime I get a t that's greater than 1.711 on this particular test, I'm going to reject the null hypothesis. If you think about that, what that really means is that when let's say my x bar is here, this would be 1.711 now. If my x bar gave me a t that was greater than 1.711, then the area here has to be less than 0.05, because the blue area here would be 0.05. So anything above this region right here, that has to be an area of less than 0.05. If the area is less than 0.05, then the p-value is less than 0.05. Basically, it's another way of looking at how do we reject the null hypothesis. Okay? I'm sure we'll visit that later. I think there's a question or two about that. What I really wanted to do is start with free response 3. So if you can entertain me with that. Okay, we have 16 students in the 2011 AP Stats Period 3. Have the following scores on their Chapter 12 tests, significance testing. How ironic. Does this sample confirm that the mean score is greater than 500? Okay. Part A. Define the population characteristic. Okay. So that's mu. Mu is going to be the average score on the Chapter 12, not just any Chapter 12, statistics, Chapter 12 test in 2011. No. Okay, so that's our population. We need a pair of hypotheses. H naught mu would be equal to 500, I believe. 500. Alternatively, we could say that mu is greater than 500. And that's basically what they're asking for. They're trying to see if we're trying to see if the Chapter 12 average is greater than 500. Does the data deviate from normality? Let's comment on all three graphs in question. Okay, so I think we're going to have to start putting those numbers into our calculator. So we can just look at the three graphs. Let's see. Let's clear off these lists.
That's all you have to do for A? Just H or
Yep.
J?
Let's see, 500, 481. I think I messed that up. 723, 850, 504, 542. Yeah, I did. 596, 265. Ooh. 400 and 215. Yikes. 735 and 950. 654. 850 and 608. 315. First thing to note is that we have a small sample, so the central limit theorem isn't going to help us. We're not told anything about the population, so the population is not necessarily normal. We do have to check all three graphs. Let's start. Let's do this. We're going to do second. F1, we're going to go to the stat plot. We're going to look at the first plot. We'll turn it on. And let's just start with a histogram. Histogram with L1. Oops. Sorry. Histogram with L1. And we'll zoom 9. Okay. Okay, certainly that histogram does look left skewed, but it doesn't necessarily deviate, or it doesn't look too bad. Let's put it that way.
Is it right skewed or left skewed?
Right skewed. Did I say left skewed? Sorry. It's a right skewed graph. Right skewed histogram. There's nothing here that suggests that it's not centrally weighted. You could certainly imagine that we could get a few more here, a few more here. So let's take a shot at that. Let's see. So what are we saying about this? A histogram.
Almost single.
Yeah, a histogram. Well, no, that's pretty single peaked. Histogram looks single peaked. Slight right skew. Does not contradict normality. And you're just kind of looking for single peaked. As long as you're single peaked, you're going to be okay. Let's take a look at the next graph. Our next graph is going to be the modified box plot. So again, here we go with the modified box plot. We're going to go back to stat plot. And we're going to change it to the box plot that shows outliers. Verify that we're still in list 1. Zoom 9. Hey, that's pretty good. I mean,
Not one.
the median's right, almost dead on the center, right? Most importantly, there are no outliers. So let's take a look at that. Let's most importantly, no outliers. The modified box plot does not show outliers. That's good. Lastly, we're going to take a look at the normal probability plot, check for linearity. Again, go back to second stat plot. Get to that very last graph. Make sure that we have the correct list, L1. Our book likes to put the data axis as the y-axis. It doesn't really matter as long as, well, you really only have two choices, so it doesn't matter. Same thing, zoom, stat. Hey, that's not bad at all, actually. Looks linear to me.
It's called the normality plot, right?
Normal probability plot. Okay, so the normal probability plot looks approximately linear. Since there are no contradictions to normality, it should be safe to use T procedures. Oh, last question. Would T or Z procedures be more appropriate? T procedures are more appropriate since we do not have the population's standard deviation. I.e., we are going to estimate the population standard deviation with the sample's standard deviation. Yeah.
Sorry, so one more time, the only times you're going to use Z are if the standard deviation of the population is known, or if we're dealing with proportions? So anytime it's with means, it's just T's unless they give us
Yeah.
sigma.
Let's put it like this. Reminder. Proportion always Z. Okay. Mean
Always T unless we have.
mostly T. Exception use Z if sigma is stated in the problem. And you have to be sure that you're given sigma. Hopefully that kind of cements things. Anything else with for response question 3? Okay, let's look at question 2, and then we're going to, I think we're going to be finishing up with that. Free response question 2. Yeah. This one actually is not meant for you to answer that question. That question's kind of only given to you so that you can figure out the alternative hypothesis. Although, you know, at this point, we could very well answer the question pretty easily. Any other questions? Good stuff. Okay, free response question 2 then. When the antihistamine Seldane was first introduced, it was heavily promoted because it supposedly did not cause drowsiness, unlike other antihistamines. A portion of prescribing information for the drug is taken from an advertisement. You get this nice chart. Is the proportion of patients reporting drowsiness while using Seldane greater than the proportion of patients reporting drowsiness using a placebo? Carry out a significance test to support your conclusion. Okay. So this is now a proportion. So step 1, you should just go through those. Population characteristic. So pi is going to be equal to the proportion of patients using Seldane that report drowsiness. Step 2. Hypotheses. Null hypothesis. Pi is equal to 8.1. 8.1 is the proportion of people, a proportion of placebo patients who report drowsiness.
So we're starting with placebo.
Well, we want to know if Seldane has greater proportion of drowsiness than the placebo. So we start off by assuming that they have the same. Reporting drowsiness using placebo. Remember, placebo patients are not actually taking a medication. Alternative. Pi is greater than 8.1. And that's the question that they're asking. Is the proportion of patients using Seldane greater than placebo? Is pi actually greater than 8.1? Yeah.
I'm just a little confused. Doesn't proportion have to be under 1?
My gosh, you're right. Sorry about that.
Why?
Proportions are always between 0 and 1. It's kind of by definition. I can't believe I did that. Thank you for that. Good catch.
And now it's recorded forever.
Now it's recorded forever. Thanks for reminding me about that. Step 3 is our conditions, right? Okay, the first condition is, well, what is mu pi? .081. What is sigma pi? Well, that's the square root of 0.081 times 0.919 divided by our sample size. What's our sample size? 781?
How come you're choosing the one and not 6?
Because I want the sample of people who took Seldane.
Trying to find the proportions of people to Seldane.
So,
Yeah.
so even though you got the proportion from the placebo, we're using the n from the cell.
Yeah, because we're testing Seldane. We're not testing the placebo. We're testing Seldane. Okay, and lastly, n times pi. That's going to be equal to 0.081, yes. 781 times 0.081, which is greater than 10. N times 1 minus pi. That's going to be 781 times 1 minus 0.081. Yeah, that's greater than 10 also. Since the sample size is large enough, it is safe to use Z procedures or normal procedures. Okay. Calculations, step 4. Test statistic is a Z. Okay, that's going to be equal to, I should put this down here, it's P minus pi, no, minus mu pi divided by sigma pi. P is
0.009.
009, yeah. No, 09.
Yeah,
Point 09 minus 0.081
still 7.
divided by 0.0098.
Why are we using .0?
That's the proportion using reporting drowsiness while on Seldane. 9%.
Why are we using that instead of I'm confusing because the proportion is always less than when you use the placebo one.
The only thing we're using for placebo is 8.1%. Because remember, we're testing the Seldane patients, not the placebo patients. Okay, that's pretty good. 0.918, 0.92. Probability of Z being greater than 0.92. That's to our calculator now. We're going to go distribution, normal CDF, 0.92 to 1 E99. One 788. A screenshot for you. Oops. Let's do that again. Much better.
The numbers are wrong. This is first 0.74.
0.74.
But I probably thought I'm looking at the answer.
Yeah. Yeah, I don't know why why that's there. Interesting. That's all the calculation we need to do.
Since it doesn't give us alpha, we're going to use the 5%.
Hmm?
Since it doesn't give us alpha, we're going to use 5%.
Decision and summary. Since the p-value is greater than alpha, okay, we fail to reject the null hypothesis. If the null hypothesis was true, there is a 17, almost 18% percent chance. We use chance or probability of obtaining our sample. Since this is likely, was that we conclude that there is no evidence that pi is greater than 0.081. I'm sorry,
No.
you have to do this in context. That the proportion of patients reporting drowsiness Alright, so there's no evidence that the proportion of patients reporting drowsiness while using Seldane is greater than 8.1%, which would be the proportion of patients reporting drowsiness while taking a placebo treatment. Does that mean people who you take Seldane don't get drowsy?
No.
Why do we fail to conclude the null hypothesis if we got 18%, which is greater than 5%?
We reject if the p-value is less than alpha.
Because the assumptions are based on
Yeah. So notes. Reject if p-value is less than alpha. Fail to reject if the p-value is greater than alpha. I think we said less than or equal to. Any questions? How are we doing? Okay, well, that's that.